And we had already studied the first section of derivative lipids, that was cholesterol, the vitamin D, vitamin A, E and K, that were from isopropyloids. And then we had also studied the bile salts. Then we had studied the role of cholesterol. Okay, so today what we are going to do is going to take up the eicosanoids. Out of eicosanoids only, we are going to deal today with the prostanoids because it is a big family and very important for physiology and biochemistry. So I have divided it into two parts. So basically, what are eicosanoids? As the name indicates, eicosanoids are compounds derived from icosa, or icosa means 20. So any fatty acid which is of 20 carbon, derivatives of those are eicosanoids. You all know linoleic acid, linoleic acid, arachidonic acid, and icosapentaenoic acid. They all are fatty acids of 20 carbon. The only difference is whether they are three double bonds, four double bonds, or five double bonds. So based on whether it has three double bond, four double bond, five double bond, when they undergo oxidation, they can produce very important biochemically and pharmacologically important compounds which are known as eicosanoids. So eicosanoids are nothing but compounds synthesized from 20 carbon chain fatty acids. In the human system, normally it is predominantly from arachidonic acid, whereas the pathway, similar pathway does exist from the other arachidonic acid who has four double bond, whereas the same pathway operates to produce their different isomers with three carbon, three unsaturated carbon, or five unsaturated carbons. Okay, but today we are going to emphasize predominantly on the arachidonic acid pathway when it comes to prostanoids. So these compounds are very important because they have both physiological and pharmacological role to play. You know what is pharmacological role? When you can use them to treat a disease or a drug, as a drug, you can use them. So they are very important for physiological regulators and also has an application for pharmacological use. Okay, so they are hormone-like molecules. You all know that it can hormone can either be endocrine or exocrine. But besides this, there are some other hormones which are either autocrine or paracrine. So you know, endocrine hormones are ductless hormones, exocrine hormones are with duct. Besides this, there are certain local hormones which are produced and they act either on the same cell, that is autocrine, a hormone produced by a cell acting on its own self, or it is known as autocrine action. और इट कैन बी अ पैराक्राइन. पैराक्राइन मीन इन द विसिनिटी, जो आसपास के एक दो सेल्स हैं उन पर अगर एक्शन करता है तो दैट इज नोन एज पैराक्राइन सेल्स, पैराक्राइन हार्मोन. सो नॉर्मली दिस hormonal activity associated with eicosanoids are of paracrine or autocrine in nature, and so they become very important in local regulation. Basically, eicosanoids can be of two types, whether they are cyclic or they are non-cyclic or acyclic. So the acyclic group, leukotrienes and lipoxins, which we will be dealing in the next lecture. Today's lecture is on prostanoids. Prostanoids are nothing but cyclic compound formed by internal cyclization of eicosanoic acids, forming either a 5 carbon member or a 6 carbon ring member. Okay, so basically there are three types of prostanoids described as prostaglandins, prostacyclins, or thromboxane. And based on the origin or the precursor, if it has three double bond, due to cyclization, two double bonds will be utilized, and as a result, only one will be left. So you will have the PGE1. PGE1 means nothing but one double bond left in the final structure. PGE2 means two double bonds left in the final structures. So it started from four, two were used in cyclization, and two are left on the molecule. So PGE2 means two double bonds left on the molecule. PGE3 means because icosapentaenoic acid has 5 double bonds, so out of which 2 will be used in cyclization, and the remaining 3 will be there, and so the product in that case will be PGE3. Okay. Now, why icosanoids are important? As I said, they are very important in many bodily functions, especially inflammatory response और लोकल इंजरी. जब कोई हिट लगती है, पेन या इंजरी होती है, तो बॉडी हैज टू हील. सो इन सच responses, inflammatory responses, or due to injury or injection, there will be a local reaction. So there, icosanoids come to play into a role. So the inflammatory response is the sum of the total body's efforts to destroy the evading or to heal the damage done by injury. Okay, and as a result of this, you always feel a sensation of pain, swelling, and followed by a fever. तो ये रिएक्शन भी इन मॉलिक्यूल से ही गवर्न होते हैं, which makes you feel the perception of pain by the nociceptive receptors or the pain receptors, or then there will be a swelling because there will be a loss of fluid or loss of blood, उससे swelling होगी. Okay, or then ultimately you may also feel fever, and in some cases there can be a hypersensitivity or allergic reactions occurring due to this. Now, besides this, they also have a role of vasodilation or vasoconstriction. You all know कि अगर कोई रिएक्शन होगा और उसको हील करना है, तो या तो आपको ब्लड वेसल्स को श्रिंक करना पड़ेगा या ब्लड वेसल्स को एनलार्ज करना पड़ेगा. और इसी तरह से इट आल्सो हैज रोल इन टर्म्स ऑफ bronchial physiology, whereas it can either cause the bronchioles to contract, this is bronchoconstriction, और bronchodilation. अस्थमा में इसको बहुत क्लासिकली एग्जाम्पल सिखाया जाता है, बट इट ओवरऑल इट प्लेज अ वेरी इंपॉर्टेंट रोल इन बोथ द मसल दिस arterial or vascular constriction plus bronchoconstriction or bronchodilation. So the first family which we will be dealing today is prostaglandins. So prostaglandins are diverse. As I said, it can be either numbered as 1, 2, 3, 4, 1, 2, 3 based on the number of double bonds, or it can be named from A, B, C, D, E, depending on the substitution it has on the side ring. So initially, first the PGE was discovered and it was ether soluble, and then F was discovered, which was a phosphoropropyl solution. तो पहले तो जो classification किया गया था, that was only just based on whether it is ether soluble or it is phosphoropropyl solution. But now we have very many other prostaglandins known, and the nomenclature is A, B, C, D, E, and we have another group which was first a prostaglandin, but now it is a prostacyclin because it has an entirely different or antagonistic role. So it is now given a name PGI, but it is given a separate group which is known as prostacyclin. So prostaglandin A to E, and then prostacyclin I. Now it is a separate group because it has an opposite role to thromboxane. So that's why it has been now grouped separately, and you have prostacyclin and you have prostaglandins, and then you have thromboxane. So prostaglandins were first discovered in human semen way back in 1935 by a Swedish physiologist by name Ulf von Euler. Okay, and since it was isolated from prostate gland, he thought it is only from prostate gland, and he gave the name prostaglandins. But now it is known that prostaglandins practically are present in each and every cell, The only thing is one cell type produces only one type of prostanoids. That is a uniqueness that you don't have multiple prostanoids produced by the same cell. One cell will produce only one type of prostanoid. So it is very because it has a localized action. So it has to be a cell specific action, and that's why nature has given this care to produce one type of prostanoid per type of cell. The understanding of prostaglandins came into much more enlightened later on in the 60s and 70s by three biochemists, and they have subsequently got the Nobel Prize in 1982. That was Bergstrom, Samuelson, and Robert Wayne. These three scientists, two Swedish and one British scientist, they together worked on identification of total spectrum of prostaglandins and role to determine their function, and they all three jointly shared the Nobel Prize. So basically, prostaglandins, or what we are going to study today, are prostanoids. So what is prostanoids? Prostanoids are nothing but, as I said, a cyclic derivative of the 20 carbon fatty acid. Okay, so this is basically the basic prostanoic acid from which the entire spectrum of the three chains, the three types are produced. So designed by, as I said, A, B, C, D, E. That's a E will be in prostaglandins, and I will be a part of prostacyclin. And the number of double bonds are the subscript. So PGE1 means one double bond, PGE2 means two double bond, and PGE3 means three double bonds. So this is your typical arachidonic acid, which, as I said, has four double bonds. So two of the carbon will be utilized for cyclization, and as a result, only two double bonds will be left. So it will be PGE2. Okay. So you have two double bonds left, whereas you have two carbons which were in this were used for cyclization to produce a five-membered internal ring with a attached double bond O or double bond or OH. So here there is a slight mistake by the author anyway. So the cyclization process in the first part, that is what we are dealing with the prostanoids. So here it should be prostacyclin and not LT. Okay. In the second part, which is the non-cyclic products, we don't have any cyclization. So cyclization occurs only in the three first groups, that is prostaglandins, prostacyclins, and thromboxane. And so it is wrongly been mentioned here as LT. It should be prostacyclin PGI. Okay. Error happens by making the slide no. So that's what I have tried to again mention here, correcting the error in the slide. Now, so all these fatty acid derivatives, as I said, are important in inflammation, fever, and pain, and caused by injury or disease. They are important in formation of clots, and they are, as I said, by maintaining homeostasis, by renal excretion of sodium and fluid, they regulate the blood pressure. And similarly, the gastric acid secretion and the gastric lining are very well protected by prostaglandins. Otherwise, gastric juice has a pH of something around 2. And if the cells, mucous cells of gastric are not protected by this secretion, you will get ulcers formed in the stomach. That's called gastric ulcers. So, prostaglandins play a very important role in protecting the lining of the gastric mucosa or gastric health in general, which we will discuss in detail later on. So, as I said, linoleic acid, or arachidonic acid, or eicosapentaenoic acid. These are the four main things. So, basically, you can see that there are three possible pathways. The first one, in which you have three double bonds forming the one series, four double bonds forming the two series, and the five double bonds forming the three series. Okay, but we need not know all the pathways, and because they are exactly parallel. The only thing end product, so साइड चेन की है वहाँ दो बॉन्ड है, एक बॉन्ड है या तीन बॉन्ड है, वो फर्क आएगा, ठीक है ना. So to understand, we will be concentrating only on the two pathway, that is ultimately PGE2 pathway. Now, and the arachidonic acid, which I said was with four double bonds. The advantage here is that you can either have it the dietary pathway or that from the phospholipid. Last time, if you remember, when I taught you phospholipid, I specifically mentioned that the second chain attached to phospholipid is invariably a unsaturated fatty acid. If you remember, I had emphasized that point that time. This because of this reason today that arachidonic acid in the local reaction, which has to be immediately released after infection or injury, is by phospholipase A2 activity. Phospholipase A2 does nothing but leaves the second arachidonic acid on the phospholipid. On the phospholipids कार्बन नंबर 2 पे जो आपका arachidonic एसिड है उस पर phospholipase A2 एक्ट करेगा और जी अगर जरूरत है प्रोस्टाग्लैंडिन प्रोस्टासाइक्लिन या थ्रोम्बोक्सिन प्रोडक्शन की तो इमीडिएटली वहां पर वो एक्ट करेगा एंड एज अ रिजल्ट arachidonic acid will come down for producing the eicosanoids. Okay. So there are 2 points. That for the first part is the cyclic part and the second is non-cyclic part, and the source is common. ऐसा होता है ये पॉइंट यहाँ इसलिए समझना जरूरी है क्योंकि देयर इज ऑलवेज अ कंपटीशन बिटवीन द टू. I think I should have added a slide. There will be always be a competition. ओके सो अगर ये दोनों का ओरिजिन एक है तो अगर ये पाथवे किसी कारण से ब्लॉक होगा तो सारा एराक्रोनिक एसिड इसमें चला जाएगा और अगर ये दोनों साथ में चल रहे हैं तो देयर विल बी ऑलवेज बी अ खींचतान चलेगी क्योंकि सप्लाई कॉमन है तो आइदर इट विल ट्राई टू ड्रैग टू दिस और ट्रैक टू दिस और कॉन्वर्सली इफ यू ब्लॉक दिस द एंटायर एराक्रोनिक एसिड विल गो टू दिस. This is very important in case of asthma because when you use drugs without knowing that asthma, it's quite possible that these are harmful for asthma. आपने इसको ब्लॉक किया electronic हो रहा है because of the stress or will go to this pathway and create a lot of problem to the asthmatic patient. So they not only act as competitors but they also have to take care if you are doing pharmacological investigation. You have to take care that you block selectively so that you don't put the patient into trouble. Also, we are done. I should have included a slide here only. It's okay. Now this is what I was trying to tell. That you don't have to think a lot about it. I'll be dealing each part separately again. So आप ये समझो कि यहाँ पे अगर 3 डबल बॉन्ड हैं और 2 साइक्लोजिन में चले गए तो एज अ रिजल्ट यू विल हैव ऑल द मॉलिक्यूल्स व्हिच विल हैव ओनली 1 कार्बन दैट इज PgE1 PgF1 एंड थ्रोम्बोक्सिन A. सो और अगर इस दिस इज लिनोलिक एसिड सो इफ लिनोलिक एसिड फर्दर अंडरगोस रिमूवल ऑफ 2 कार्बन इट कैन प्रोड्यूस arachidonic acid. Okay, so arachidonic acid can come from linolic acid subsequent dehydrogenation or it can come from the membrane. Membrane पे phospholipase A2 act करेगा और as a result of this to produce your prostaglandin D or prostaglandin I2 or thromboxane. Here this all have come, all the 3 have come, prostaglandin, all the 3 prostaglandin, 1 prostacyclin and 1 thromboxane. You only have prostaglandin and thromboxane. Prostacyclin is not produced by this pathway. So when it comes to releasing the arachidonic acid from the membrane, these are the stimulants. This will trigger the phospholipase to release arachidonic acid from the membrane. मेम्ब्रेन की फॉस्फोलिपिड पे जो arachidonic acid है उसको क्लीन करने के लिए जो फॉस्फोलाइपेज A2 है उसको एक्टिवेट कौन करेगा? एंजियोटेंसिन सिस्टम, यू नो इट इज. देन यू हैव ब्रेडिकाइनिन, then you have your epinephrine and then you have thrombin which is a blood clotting factor. ऐसे जो important functions है उनको रेगुलेट करने के जो भी चीजें हैं वो इसको स्टिमुलेट कर arachidonic acid and then release arachidonic acid to produce the prostaglandin, prostacyclin or thromboxane depending on the target tissue where the secretion has occurred. Now, if you have a 5-step arachidonic acid, of prostaglandins, and you start with 5 carbon, 2, so then you have the prostaglandin produced. So remember, so just explaining them in one by one, and we will only be discussing the electronic acid know how the reaction is. But as it is, we have lost 15 minutes today. Because see the so here electronic acid, you first have carbon. The result you have a 3 double bond structure, which is 8, 11, 14. Okay, you have 3 double bond. There are 8. Try these 2 enzymes, cyclooxygenase, which will study next. You have the production of PGE1 and thromboxane 1. Hence, we will be studying separately in the next lecture. Now, this is the important part, most extensively studied, important for you to know. Part is the carbon of the phospholipid, giving you free arachidonic acid, which can also come from nucleic acid, and then by the action of 2 important cyclooxygenase oxidase, you have 2 formation of prostacyclin and then thromboxane. So the first reaction is prostaglandin. It is prostaglandin H prostaglandin H. तो प्रोस्टाग्लैंडिन एच सिंथेज, क्योंकि प्रोस्टाग्लैंडिन एच से ही सारे डाइवर्ट होते हैं, पांचों उसी से डाइवर्ट होंगे, वो नेक्स्ट स्लाइड में पता लगेगा। इसको बनाने के लिए आपको 2 एंजाइम चाहिए। फर्स्ट एंजाइम इज साइक्लोऑक्सीनेज एंड द सेकंड एंजाइम इज पेरोक्सीडेज। ओके, and by virtue of diversity or regulation, it occurs in 2 forms, that is PGHS1 type and PGHS2 type. Okay, next for this point we will cover again next slide. So as I said, there are 2 enzymes. The first is the cyclooxygenase. Cyclooxygenase का short form है COX. COX are of 2 types. The third type is recently discovered, not very prevalent, but it is coming up in the pharmacological field. The COX one is the good cyclooxygenase. Why it is good cyclooxygenase? Because it is a constitutive enzyme. It is a constitutive enzyme. We all know that certain enzymes are under regulation or under control, whereas certain enzymes, they are housekeeping enzymes, and you cannot take the chance of producing them at will. मतलब अपनी मर्जी से बनाओगे तो काम नहीं चलेगा, आपको हर समय वो बनने ही चाहिए to keep somehow. So they are from the housekeeping genes. Housekeeping genes produces housekeeping enzymes. So a minimum enzyme activity of them always occurs invariably, irrespective of the size, shape, and stage of the cell. So COX1 is of housekeeping type, and why it is so, as I said you, it is very important in maintaining the gastric mucosa lining. Secondly, maintaining the homeostasis. You all know you cannot afford to be imbalanced internally. So internal balance बनाना है आपको, blood pressure, fluid volume वगैरह का, तो homeostasis has to be maintained and by targeted renal function. So as a result, the COX1 enzyme is termed as a good enzyme or a good boy because it is all throughout the entire life of the cell operates at a minimum level required to keep the status. The COX2 is labeled as bad guy because ये वो part होता है जो induce हो जाता है जब कोई stimulation मिलता है. Okay, normally COX2 is very insignificant amount in normal condition, but the moment you have a cytokine or interleukin necrosis factor or any other abuse which needs more of the prostacyclins, the prostanoids in general. तो ये उसको बढ़ा देगा, तो ये एंजाइम उस समय इंड्यूस होगा। COX-2 इज एन इंड्यूसिबल एंजाइम एज पर रिक्वायरमेंट। सो COX-2 is induced by any stress। पर ये जो आपको पता है, लास्ट टाइम आई टोल्ड यू कॉर्टिकॉइड्स आर स्ट्रेस बस्टर्स, जब अपन स्टेरॉइड हार्मोन्स पढ़े थे। तो हाउ आर दे आर स्ट्रेस बस्टर्स? बिकॉज जो स्ट्रेस का जो रिएक्शन आना है उसको ये रोक देगा। तो कॉक्स का जो भी इंडक्शन होता है COX-2 का, दैट कैन बी प्रिवेंटेड बाय कॉर्टिकोस्टेरॉइड्स। सो अगर आपको कोई स्ट्रेस हुआ है और उसके खातिर COX-2 बढ़ना चाहिए था और आपने स्टेरॉइड ले लिए है, तो COX-2 नहीं बढ़ेगा, तो वो स्ट्रेस का जो आपको फिजियोलॉजिकल इफेक्ट आना है वो नहीं आएगा। ओके, बी इट अब्यूसिव स्ट्रेस और एनी टाइप ऑफ स्ट्रेस। So COX-2 is inducible, but the induction can be blocked by corticosteroids. Okay, and so because of this reason only, you have the extra reaction occurring, which I told you before. They cause inflammation or pain or fever. Okay, recently COX-3 has been also been identified. Not recently, maybe 15 years back, 20 years back, and the only thing is it is a variant. So intron है क्या, वो extra है इसमें। Okay, and people are trying to find out the added advantage of using it because it is inhibited by amino acetophen। Okay, so इसका pharmacological role के हिसाब से COX-3 variant। Now you also should know that see, corticosteroids are steroidal hormones। Besides this, you also have non-steroidal anti-inflammatory drugs। NSAIDs means nothing but non-steroidal anti-inflammatory drugs, जो आपके अंदर कोई भी स्ट्रेस से अगर इन्फ्लेशन होता है उसको रोकते हैं। तो उसका कॉमन एग्जांपल है एस्पिरिन। ओके, सो non-steroidal anti-inflammatory drugs are normally non-specific and they can act on both COX-1 and COX-2। Okay, what aspirin does is nothing but acetylates, उसमें एंजाइम के ऊपर एसिटाइल का मॉलिक्यूल लग जाएगा। एज अ रिजल्ट दिस एंजाइम विल बिकम इनएक्टिव। ओके, द COX-2 which is a notorious element, अगर आपको उसको सेलेक्टिवली इनहिबिट करना है, सो देयर इज people have designed drugs। यहाँ थोड़ी गलती हो गई है, इवन इन दिस स्लाइड देयर इज एन एरर। जो एक्चुअली COX-1 की जगह COX-2 इनहिबिटर है। क्यों? बिकॉज इट इज द नेम इज साइक्लोकॉक्स। ठीक है, 1B, 1B इज द 2, उसने 2 ने लिख के इसको 1B नेम किया है। और इसी तरह से सेकंड दिस ड्रग इज 1B। सो दिस ऑल आर नथिंग बट COX-2 inhibitors, they are not COX-1 inhibitors। Okay, similarly you have, this is for the next slide। So glucocorticoids, what they do is they inhibit the release of arachidonic acid because they produce annexin। This annexin is an inhibitor of phospholipase E2। Okay, and it has also the property of inhibiting the induction of COX-2। So since these molecules are very active, they have very short half-life and they are instantly, maximum life is 30 seconds। So what happens is there is a phenomenon known as cell suicide। They are so made that they kill themselves। Okay, so the prostaglandin activity is remarkably achieved by the property of cyclooxygenase, which is the self destruction and also known as suicide enzyme। Cyclooxygenase जब बनता है, especially the COX-2 type, it doesn't remain for long, it tries to kill itself fast, so ताकि उसका कम रिएक्शन होगा। ठीक है, so that is the way how the further production is stopped and the half life, as I said, is very short। so बना, अपना काम किया और खत्म। बनना भी थोड़ी देर बाद हो जाता है। और आई थिंक क्लास तो मेरे को कंटिन्यू करनी पड़ेगी यार, आज तो टाइम होगा भी नहीं। चलिए, नाउ दिस इज अ की for you to understand the total prostaglandin production from arachidonic acid। So this is your arachidonic acid। So the first enzyme is cyclooxygenase, which you have already told is inhibited by aspirin indomethacin or ibuprofen. They are the non-steroidal anti-inflammatory drugs. And what is this is nothing but it adds two molecules of oxygen internally, and as a result you have uh, an OH here and a double bond here. So two molecules of oxygen are incorporated by the action of cyclooxygenase. And as a result, you have the first prostaglandin produced, which is called as PGG2. PGG2 is very transient. It doesn't stay for long, and it is immediately acted upon by another enzyme, peroxidase, to give you a first stable product, which is known as PGH2. PGH2 is the father of all the prostaglandins, prostacyclin and thromboxane. ये आपका PGH2 जो बीच में बना है, ये आपका first stable compound है by the action of the two enzymes cyclooxygenase and peroxidase. Okay, PGH2 में पहले अपन देखते हैं PGE2. Okay, so PGE2 is nothing but isomerization of PGH2. PGH2 में आपका आइसोमराइजेशन हुआ कैसे? आप यहाँ देखो, ये डबल बॉन्ड ओ, दो ओ ऐसा लगे हुए हैं, और यहाँ क्या हुआ है, ये डबल बॉन्ड ओ और OH हो गया. सो ये PGH2 का PGE2 इज नथिंग बट आइसोमराइजेशन, इंटरनल आइसोमराइजेशन हो गया है, और O वो बॉन्ड था वो शिफ्ट हो गया है, एंड एज अ रिजल्ट यू हैव योर PGE2 फॉर्म. ओके, PGE2 से PGF में नथिंग बट देयर इज अ रिडक्शन. No, reduction is this part, sorry. Reduction is this reaction. In this reaction, when PGF uh, occurs directly, it is a reduction because you have a double bond added. Just a moment. Where is it? Double bond. Okay, yeah. This is a reduction of this. Sorry, this is a reduction of this. This double bond O has come OH. So this H is added here and H is added here. So as a result, there is a reduction, and you can see that PGH has been converted to PGF2 alpha. Similarly, here also there is a reduction where OH or double bond O is converted to OH. Okay, so nothing but reduction of either PGH2 or PGE2 leads to formation of PGF2 alpha. You have another prostaglandin PGD2 which is also an isomer. फर्क क्या है, यहाँ पे देखो आप डबल बॉन्ड O ऊपर है और OH नीचे है. ठीक है, एंड इन दिस आइसोमराइजेशन द डबल बॉन्ड O इज ऑन द लोअर साइड एंड डबल बॉन्ड 9, 10, 11, 9 और 11 में जो डबल बॉन्ड और OH थे वो इंटरचेंज हो गए. PGE2 में डबल बॉन्ड O 9 पे है और यहाँ पे आप डबल बॉन्ड O 11 पे है. सो ये भी आइसोमराइजेशन है, ये भी आइसोमराइजेशन है ऑफ द PGH2. PGH2 का आइसोमराइजेशन से PGE2 भी बन सकता है और PGD2 भी बन सकता है. ओके, एंड द ओनली डिफरेंस बिटवीन दिस टू इज वेदर इट इज ऑन 9, 11 और 11, 9. ये फर्क है इसमें. ठीक है. नाउ व्हेन इट कम्स टू प्रोस्टासाइक्लिन, a separate group which act entirely different, you have this pathway where you have यहाँ पे आपने देखा कि ये O डबल बॉन्ड O यहाँ है, ये यहाँ से शिफ्ट होकर यहाँ चला गया. The O attachment which was here in PGH has now moved to this place. So this is the prostacyclin synthase does nothing but relocates this this OO from here to here. You can see, and now this has become an entirely different, entirely opposite acting group of eicosanoids which are termed as prostacyclin. ये तीनों प्रोस्टाग्लैंडिन थे, ये प्रोस्टासाइक्लिन है. ठीक है. और when it comes to thromboxane, तो thromboxane synthase क्या कर रहा है, इंटरनल O और एक O. ठीक है, ये चीज नहीं बन रही है यहाँ पे. तो thromboxane synthase does nothing but ये जो बाहर था इसको अंदर ले लिया है और यहाँ पर एक O into, as a result this has become a 6-membered ring now. This was a 5-membered ring here, now here is a 6-membered ring with an O. Okay, ईथर बॉन्ड बीच में बन गया और एज ए रिजल्ट ये जो ओ थे ये अंदर आ गए. So this is the basic change done by thromboxane synthesis. Okay, and as a result, the end product is, after that it is cleaved. This O is cleaved, and you have your OH here, and this is your thromboxane B2. Okay, this is for blood clotting. So this is in short because we have passed it. Okay. So this is arachidonic acid. Uh, Arachidonic acid can either be acted by COX-1 or COX-2 and then peroxidase to give prostanoid H, which is the first stable compound, and this can give rise to PGE2. PGE2 in terms can cyclize to give the other two, PGF2 alpha and PGT2. वो हमने बताया था, इसके प्रोडक्ट यहाँ लिखे नहीं है मैंने, पर you are seen in the previous slide. They all come from this same pathway. Similarly, it can also form prostacyclin, PGI2, and then thromboxane. So these three are your prostanoids, whereas this is the lipoxygenase other pathway, which we will be discussing later on in the next class. Maybe even we will have to continue this only next time. So this is in short what I had mentioned before, that there are three types of prostacyclin synthase for PGD2, which is nothing but isomerization, no doubt, and PGE2, that is also isomerization, and PGF2 alpha, addition of oxygen and cleaving again. Then this is the site for thromboxane, and this is the site for prostaglandin, prostacyclin. These three. Now I can just go on to, yeah. So don't go for the structure, just go for important biological function. PGD2 has a very important role in mast cell maturation. It is very good important in vasodilation. Uh, you know what is vasodilation? Nothing but increasing the blood flow. And then eosinophils and जो आपके रिएक्शन में काम आते हैं, इम्यून रिएक्शन में एंड एलर्जी रिएक्शन में, तो इओसिनोफिल का को मूव करना, उस जगह भेजना, इसका काम किसको दिया गया है? PGD2 को. ठीक है, आई हैव एडेड वन मोर. दिस इज द सेम थिंग इन मोर डिटेल, जो स्लाइड में पढ़ लेना बेटा. क्योंकि सिमिलरली द PGE2 हैज vasodilation and control of vascular leakage. Then it is the factor causing fever. It is also responsible for analgesic effect, hyperanalgesia. Then it decreases the gastric acid production and increases the gastric mucosa secretion. This is a very important function which I had mentioned to maintain the health of the stomach. अगर एसिड सिक्रेशन कंट्रोल नहीं होगा तो भी प्रॉब्लम होगी, और म्यूकोसल लाइनिंग प्रॉपर नहीं रहेगी तो भी प्रॉब्लम होगी. And so to maintain the gastric health, this important PGE2 plays a very important role. Then it increases the uterine contraction. This is something more added to it. Class again. PGF2 alpha is responsible for causing vasoconstriction. It was vasodilation, this was vasoconstriction, uterine constriction, and bronchoconstriction. Okay, these are the three important functions associated with PGF2 alpha. So this is the third group, which I said coming from eicosapentaenoic acid, and then eicosapentaenoic acid leads to production of four double bond variants, three double bond variants. Sorry, 5 है तो 2 काम आ जाएंगे, 3 बचेंगे. That is PGD3, PGE3, PGF3, PGI3, and thromboxane A3. These are the important prostaglandin, prostacyclin, and thromboxanes produced from eicosapentaenoic acid, coming from either linoleic acid or per se as it is. They are all essential fatty acids. This all we have done. I think I stop here only. Rest you can all read yourself. Okay, I forgot to tell about thromboxane and prostacyclin effect. Okay, thromboxane is synthesized from platelet and upon release causes vasoconstriction and platelet aggregation. जो आपका ब्लड फॉर्मेशन होता है, रोकने का काम है, वो किसको दिया गया है? थ्रोम्बोक्सिन B4, B2 और B3, दो ही तरह के होते हैं. ठीक है ना. और व्हाट इज रोल ऑफ प्रोस्टासाइक्लिन? Prostacyclin is produced from blood vessel and it is a potent inhibitor of platelet aggregation. So thromboxane और prostacyclin का just opposite effect है. So that's why that was the reason why prostacyclin was given a separate group. Okay, so prostacyclin and thromboxane, these two have entirely opposite or antagonistic effect. एक से कुछ हो गया, एक से तो कंट्रोल करने के लिए दोनों काम में लिया जाता है. This is all important. Thromboxane का काम मैंने आपको बता दिया. So I think all you may have to read from the slide beta because I have covered a lot part later on also. So prostacyclin, now thromboxane was for blood clotting, uh, prostacyclin was for vasodilation and decreased platelet aggregation. Okay. Now, besides this, I have covered a lot of physiological. So this is in nutshell the overall pathway which you should know. उसके अलावा कुछ स्लाइड मैंने और इंक्लूड की है. Since I was making it, I thought of making it for PG also. वो आप पढ़ लेना अपने इंटरेस्ट से. So phospholipid में this is the point where your glucocorticoid acts, and this is the point you should take care by treating the asthma patient because आप ये नहीं चाहोगे कि एक बीमारी से हटे दूसरे में चले गए. Okay, so you have to deal with it. Now we have selective inhibitors for COX-2, and as a result, the by giving the COX-2 specific inhibitors, we are able to take care of the side effects of blocking the pathway for asthmatic patients. जो जिनको अस्थमा है उनको राहत मिले उसके लिए हमने स्पेसिफिक COX-2 इनहिबिटर्स डिजाइन किए हैं और वही देते हैं, नॉट जस्ट जनरल पाथवे. अगर इसको आप ब्लॉक करोगे तो इसमें चला जाएगा और ये सारे अस्थमा के लिए हार्मफुल होते हैं. आई वाज समझ में. सो दैट्स व्हाई वी ट्राई टू ब्लॉक बाय सेलेक्टिव इनहिबिटर्स सो दैट COX-1 कंटिन्यूज और ये नॉर्मल बात से चलता रहे और अस्थमा पेशेंट का जो काम है वो होता है. ठीक है. सो दिस ऑल आई थिंक वी हैव टू वाइंड अप हियर ओनली. There are few more slides which I'll be sharing in the thing, but these are mostly dealing with the physiological part, which is good for you to know. ये सारे जो स्लाइड्स है ना बेटा आज में ये सारे अच्छे हैं आपके लिए, कभी कोई एग्जाम दोगे तो काम आएगी. They are not in biochemistry no doubt, but since biochemistry and physiology